So, hi everyone, this is Jay, your instructor for computer networks, and in this session, we are going to see the multiple access protocol and its types. So, let's begin. So, generally, there are two types of link, the point to point link and the broadcast link. Now, what is point to point link? Suppose if two devices wants to send data with each other, let's provide one link between them. So using that link, they can send and data at the same time. Now, point to point link is very simple and this system is very easy. Why? Because if one device is sending data, the other device will be receiving. If other device is sending data, the first device will receive. So there is very less chance of the collision. If there is a miscommunication or some system is, for example, not working properly, so both devices will be send data at the same time, so there will be problem in the communication. But other than that, there will be no problem in the communication in the point to point link. But if the channel is broadcast, then there is some problem. Why? Because in the broadcast link means that all the devices are sharing the same channel, and if all the devices are sharing the same channel, there should be some rules and regulation. Take example of the point to point link as, for example, you and your friend is talking with each other in the classroom, and there is no other people are there in the classroom. There is a proxy lecture, and you just two guys are talking with each other. So it means that there is a link which is shared by only you both, so there is no or very less possibility of the collision, right? But for example, if that classroom is filled with all the students, and if the classroom is filled with all the students and there is no faculty, it means that all the students are talking with each other. So if all the students are talking with each other and you and your friend are sitting at one corner and another corner of the classroom, so there is very less possibility that you both will be able to communicate with each other. Are you getting it? Right. So when there is a channel is shared by more devices, there should be some protocol. And you know, or you maybe don't know, but the protocol in your classroom is instructed by your faculty. So when there is a faculty, you all the students are not allowed to talk with each other. So it means that there is some protocol, there is some rules and regulation. When faculty will say one student can ask question, or he can talk, or he can ask for permission, right? So these are the thing which we follow in our daily life, but we are not aware of it. So we are also going to see in the computer network that when the link is shared by so many devices, there are some protocols that all the devices has to follow in order to communicate, in order to send and receive data. So you can see that the Ethernet shared wire requires the multiple access protocol. Again, the shared or the satellite communication, it also needs the multiple access protocol, the shared radio. So these are the areas where multiple access protocol is highly required. So let's see the types of the multiple access protocol. The multiple access protocol is divided into three classes. The first one is known as the channel partitioning protocol. It is the FDMA, TDMA, and the CDMA. Frequency division multiple access, the time division multiple access, and the code division multiple access. The second type is the random access protocol. The random access protocol is divided into three types: the Aloha, CSMA CD, and the CSMA CA. And the third type is control access. The control access protocol is again divided into three types: the reservation protocol, the token access protocol, and the polling. So these are the types of the multiple access protocol, and always remember, when one channel is shared by too many devices, in that case we would be required these protocols. If the channel is not shared or is shared by only two devices, there is no such need of these protocols. So in this session, we are going to discuss the channel partitioning protocol, which is FDMA, TDMA, and the CDMA. So the first type is the time division multiple access. So you can see that this is the channel, and the channel is to be used by these four devices: device 1, 2, 3, and 4. So what is the concept in the time division multiple access? In the time division multiple access, all the time is divided into slots. For example, each station can send data in their respective slots only. Station cannot send data in other station slot. For example, the four devices wants to send data. So we will allocate some time slot. For example, the device A will be having time slot of 5 seconds, and first slot will be allocated to device 1. After those 5 seconds, another 5 seconds will be allocated to the next device, device 2. After that, 5 seconds will be allocated to device 3, and last 5 seconds will be allocated to device 4. So each device can send data with their respective slot in the respective 5 seconds. If their slot is missed or they have nothing to send in their slot, they cannot send data. The advantage in the time division multiple access is that each station can send data at their maximum rate, because there is no restriction of the data or restriction of the bandwidth. So each station can use bandwidth at maximum, at peak, but the only difference, the only flaw is that they can use the bandwidth for particular amount of time. The second type is known as the FDMA, which is the frequency division multiple access. Again, you can see that this is the channel which is shared by devices the 1, 2, 3, and 4. Now, in the frequency division multiple access, the channel is divided into frequency slots. In the TDMA, we have seen that the channel is divided into time slots, but here channel is divided into frequency slot. So each station will be having one particular frequency slot, and they can send or receive data in their respective frequency only. The advantage of the FDMA is that there is no time limit. So each station can send data at any time. They can send or receive data at any time they want. There is no slot, right? But the only difference is that they can send or receive data using their given or allocated frequency only. So it means that the bandwidth is divided between these four devices. If channel is having speed of 20 Mbps, so each station can send or receive data at 5 Mbps only. So that is the disadvantage of the FDMA. The practical example of the FDMA is the radio that you use to listen music or weather update or cricket score updates, right? So in the radio, if you tune to the particular frequency, you can receive that radio. For example, for the radio Mirchi, it is 98.3. For Red FM, it is 92.5. So this, what is 98.3? It is the particular frequency, 98.3 megahertz. So when you tune to that particular frequency, you can receive the signals, right? But what is the disadvantage? That the bandwidth is limited. The last one is known as the code division multiple access, CDMA. The channel is divided into codes, and you can see that there are four devices: 1, 2, 3, and 4. In the CDMA, there is no restriction of bandwidth or restriction of time. Each station can send data at any time, but the stations are having some unique code. So you can see that the 1 has unique code C1, the device 2 has C2, 3 has C3, and 4 has C4. Before sending that data, the data will be multiplied with that unique code. Now these code are unique and they are interesting. Why? Because when you multiply the code with itself, it will become 1. But when you multiply this code with the remaining codes, it will become 0. So that is why they are known, or they are called as orthogonal codes, because when C1 is multiplied with C2, it will become 0. C1 into C4, it will become 0. C1 into C3 will also become 0. But C1 into C1 will become 1. So if 1 has sent data D1 and C1, and device 4 wants to receive data D1, so 4 should know the code of the D1 and it will multiply the C1 with the D1 C1, so it will get the D1. So in the channel you can see that all the data is there, but it is up to you that what data you want to receive. For example, you can see that in the channel there is data C1 D1 plus D2 C2 plus D3 C3 plus D4 C4. If I want to receive data D3, so we will multiply all this data with C3. So C1 into C3 will become 0, C2 into C3 will become 0, C4 into C3 will become 0, but C3 into C3 will become 1, so you will receive the D3. So that is how the that is how the code division multiple access works. And this is it for today's session. Thank you.